This video provides brief information about the artillery used by the Austro-Hungarian Army in combat during World War I.
The 8-centimeter Feldkanone M05 was a light field gun developed for the Austro-Hungarian Army in the early 20th century and served as one of its standard field artillery pieces during the years leading up to and throughout the First World War. The designation M05 refers to the year 1905, when the gun's design was finalized, although it entered regular service slightly later, around 1907. The weapon was designed and manufactured primarily by the Škoda Works, which at that time was one of the most important artillery producers within the Austro-Hungarian Empire. The gun remained in service well beyond World War I and continued to be used by successor states and even during the early years of the Second World War. Despite its name, the 8-centimeter Feldkanone M05 did not have a true 80mm caliber. Its actual caliber was approximately 76.5 millimeters, which was typical of Austro-Hungarian field artillery of the period. The gun was intended to provide direct and indirect fire support for infantry units on the battlefield, engaging enemy troops, artillery positions, and lightly fortified targets. At the time of its introduction, it represented a modern artillery system, incorporating recoil control mechanisms that allowed the gun to remain in position after firing, thus improving accuracy and rate of fire compared to older designs. One of the distinctive features of the 8-centimeter Feldkanone M05 was its barrel construction. Instead of steel, the barrel was made from a special hardened bronze alloy, often referred to as steel bronze. This choice was made because the Austro-Hungarian industrial base faced difficulties producing large quantities of high-quality gun steel. Although bronze barrels wore out faster than steel ones, they were easier to manufacture and maintain, and they proved sufficiently reliable for field service. The gun was mounted on a traditional box trail carriage with wooden wheels designed for horse-drawn transport. In firing position, it relied on a hydro-spring recoil system that absorbed the backward force generated when the gun was fired. This recoil mechanism significantly reduced the need to realign the gun after each shot, allowing for a practical rate of fire of approximately 8 to 10 rounds per minute under favorable conditions. The breech mechanism was a horizontal sliding block breech, which was robust, relatively simple to operate, and well suited to the ammunition used. In terms of ballistic performance, the 8-centimeter Feldkanone M05 fired fixed or semi-fixed ammunition, most commonly high explosive and shrapnel shells. The standard projectile weighed approximately 6.5 to 6.8 kilograms. The muzzle velocity ranged between 430 and 500 meters per second, depending on the ammunition and propellant charge. The gun had a maximum firing range of about 7,000 meters, which was considered adequate for a light field gun of its era. Elevation ranged roughly from -7 degrees to +18 degrees, while traverse was limited, requiring the gun to be physically repositioned for larger changes in direction. The combat weight of the gun in firing position was just over 1,000 kilograms, making it light enough to be moved by a team of horses and quickly deployed in the field. This mobility was a key advantage, especially during the early, more fluid phases of World War I. However, as the war progressed into static trench warfare, the relatively short range and limited elevation of the M05 became disadvantages when compared to newer artillery designs. During the First World War, the 8-centimeter Feldkanone M05 was widely used on the Eastern Front, Balkan Front, and Italian Front, where Austro-Hungarian forces faced both Russian and Italian armies. The gun proved reliable and effective in supporting infantry assaults and defensive operations, though it gradually became outdated as artillery technology advanced rapidly during the war. To address some of its shortcomings, improved variants such as the M0508 were introduced, featuring modifications to the carriage and recoil system, and in some cases improved mobility for mountainous terrain. After the collapse of the Austro-Hungarian Empire in 1918, large numbers of 8-centimeter Feldkanone M05 guns were inherited by newly formed states such as Austria, Czechoslovakia, Hungary, and Yugoslavia, where they continued to serve for many years. Some of these guns were later captured or reused by other armies, including Germany, which employed them under different designations during the early stages of the Second World War, mainly in secondary or reserve roles. In conclusion, the 8-centimeter Feldkanone M05 was a representative example of early 20th century field artillery. While it was not revolutionary, it combined reasonable firepower, mobility, and reliability, making it a valuable weapon for the Austro-Hungarian Army during World War I. Its long service life and widespread use reflect both its solid design and the rapid pace of artillery development during one of the most transformative periods in military history.
The 8-centimeter Feldkanone M17 was a field artillery gun developed by the Austro-Hungarian Empire during the final phase of the First World War. It represented the culmination of Austro-Hungarian experience gained from earlier field gun models, such as the 8-centimeter Feldkanone M05 and M12, which had revealed several shortcomings under modern battlefield conditions. By 1917, trench warfare, counter-battery fire, and the need for greater range and accuracy demanded a more advanced and reliable field gun, leading to the development of the M17. The gun was designed and manufactured primarily by Škoda Works, the leading artillery producer of the Austro-Hungarian Empire. The 8-centimeter Feldkanone M17 was intended to serve as a modern divisional field gun capable of supporting infantry operations, engaging enemy artillery, and striking targets behind the front lines. Although officially classified as an 8-centimeter gun, its actual caliber was approximately 76.5 to 80 millimeters, consistent with Austro-Hungarian artillery standards of the period. The barrel of the Feldkanone M17 was made of high-quality steel and had a length of roughly 30 calibers, which allowed for a relatively high muzzle velocity and improved ballistic performance. One of the most important technical improvements of the M17 was the use of a hydro-pneumatic recoil system. This system absorbed the recoil energy during firing and returned the barrel smoothly to its firing position, significantly improving stability, accuracy, and rate of fire compared to older designs that lacked effective recoil mechanisms. The gun was mounted on a two-wheeled steel carriage designed for field use. Early versions used wooden wheels with steel rims, while later variants featured rubber-rimmed wheels to improve mobility and reduce wear during transport. The Feldkanone M17 was typically towed by horse teams, though limited mechanical towing was also possible late in the war. The carriage provided good stability during firing and allowed the gun to be brought into action relatively quickly. In terms of elevation, the gun could be raised from approximately -5 degrees to about +25 or +30 degrees, enabling both direct fire against visible targets and indirect fire from covered positions. Horizontal traverse was limited, as was typical for field guns of the era, but sufficient for engaging targets within the gun's assigned sector. The sighting equipment included optical aiming devices, which improved long-range accuracy and effectiveness in indirect fire roles. The 8-centimeter Feldkanone M17 fired several types of ammunition, including high-explosive shells, shrapnel rounds, and occasionally smoke shells. The average projectile weight was around 6 to 7 kilograms. The muzzle velocity was approximately 500 to 550 meters per second, giving the gun a maximum firing range of about 9 to 10 kilometers. The practical rate of fire was around 10 to 12 rounds per minute, depending on crew training and battlefield conditions. Operationally, the Feldkanone M17 was used to provide artillery support for infantry units, suppress enemy strongpoints, and conduct counter-battery fire against opposing artillery. Because it was introduced relatively late in the war, it did not reach the same level of widespread deployment as earlier models. Nevertheless, it was regarded as one of the most advanced and effective field guns produced by the Austro-Hungarian Empire during the First World War. In conclusion, the 8-centimeter Feldkanone M17 stands as an important example of late-war artillery development. It combined improved recoil technology, solid ballistic performance, and reliable construction into a balanced and effective field gun. Although its service life was limited by the end of the war and the collapse of the Austro-Hungarian Empire, the Feldkanone M17 remains a notable representation of early 20th century field artillery engineering and battlefield doctrine. The 10-centimeter Feldhaubitze M14 was a medium field howitzer developed by the Austro-Hungarian Empire and was one of its most important artillery pieces during the First World War. It entered service in 1914 and was designed and manufactured by the famous Škoda Works in Pilsen, which at that time was among the world's leading artillery producers. The Feldhaubitze M14 was considered a very modern and successful weapon for its era, combining reliability, accuracy, and powerful high-explosive fire. The primary role of the 10-centimeter Feldhaubitze M14 was indirect fire support against enemy infantry, trench systems, field fortifications, and gun positions. As a howitzer, it was optimized for high-angle fire, allowing shells to follow a curved trajectory and strike targets hidden behind cover, hills, or defensive works. This capability made it especially effective on the mountainous and difficult terrain of the Italian front, as well as on the Eastern Front and in the Balkans, where conventional flat trajectory guns were often less effective. Technically, the 10-centimeter Feldhaubitze M14 had a caliber of 100 millimeters and was fitted with a relatively short but robust steel barrel. The weapon employed a hydro-pneumatic recoil system, which absorbed the recoil forces during firing and returned the barrel smoothly to its firing position. This system significantly improved accuracy and allowed for a higher rate of fire compared to older artillery designs. The gun was mounted on a two-wheeled box trail carriage equipped with spades to anchor it firmly to the ground during firing. In firing position, the howitzer weighed approximately 1,500 to 1,600 kilograms, making it heavy but still suitable for field deployment. It was usually transported by horse teams, although later versions were adapted for mechanical towing. The practical rate of fire was about 4 to 6 rounds per minute, depending on crew training and firing conditions. The maximum firing range was approximately 8,400 to 8,500 meters, which was a respectable performance for a medium field howitzer of the period. The 10-centimeter Feldhaubitze M14 fired a variety of ammunition types, most notably high-explosive shells, which were highly effective against trenches and concentrations of enemy troops. Fragmentation effects were particularly destructive, making the weapon a valuable tool for battlefield suppression and preparation fire. The shells typically weighed around 14 to 16 kilograms. Ammunition was loaded using a separate loading system, with the projectile and propellant charge loaded separately, allowing the crew to adjust the firing range by varying the charge. One of the strengths of the Feldhaubitze M14 was its wide elevation range, enabling it to deliver steep, plunging fire onto protected targets. Although its horizontal traverse was limited, this was normal for field artillery of the time and was compensated by repositioning the entire gun when necessary. The gun crew usually consisted of 6 to 8 men, responsible for aiming, loading, firing, and maintaining the weapon during combat operations. After the end of the First World War, the 10-centimeter Feldhaubitze M14 remained in service with many successor states of the former Austro-Hungarian Empire, including Austria, Hungary, Czechoslovakia, and Yugoslavia. It was also adopted and modified by Italy, where it became well known as the Obice da 117. In several countries, the howitzer was modernized and continued to serve well into the interwar period and even during the Second World War. In conclusion, the 10-centimeter Feldhaubitze M14 was one of the most effective and well-designed medium field howitzers of its time. Its combination of solid construction, effective recoil system, good range, and powerful ammunition made it a key element of Austro-Hungarian artillery during the First World War and ensured its long service life in many armies. The 10-centimeter Feldhaubitze M99 was an early modern field howitzer developed and adopted by the Austro-Hungarian Empire at the end of the 19th century. It represented an important transitional step in artillery design, bridging the gap between older rigid-mounted guns and the more advanced recoil-controlled howitzers that appeared shortly before and during the First World War. At the time of its introduction, the M99 was intended to provide the Austro-Hungarian Army with a weapon capable of delivering high-angle fire against concealed and fortified targets, something traditional field guns were not well suited to achieve. The primary tactical role of the 10-centimeter Feldhaubitze M99 was indirect fire support. Its high-angle trajectory allowed it to engage enemy infantry in trenches, behind earthworks, and in defilated positions, as well as to bombard field fortifications and artillery emplacements. This made the howitzer especially valuable in mountainous terrain and later in the trench-dominated battlefields of the early First World War. Compared with flat trajectory field guns, the M99 could drop shells almost vertically onto targets, increasing the effectiveness of its high-explosive ammunition. From a technical perspective, the howitzer had a caliber of 100 mm and a steel barrel mounted on a simple box trail carriage. The carriage was fitted with wooden spoked wheels with iron rims, making it suitable for horse-drawn transport, which was standard for artillery units of the period. One of the key limitations of the Feldhaubitze M99 was the absence of a modern recoil absorption system. When the gun was fired, the entire piece recoiled backward, requiring the crew to reposition and re-aim the howitzer after each shot. This significantly reduced the practical rate of fire and increased crew fatigue, especially during sustained bombardments. In terms of performance, the 10-centimeter Feldhaubitze M99 fired separate loading ammunition, typically high-explosive shells weighing approximately 14 to 16 kilograms. The maximum firing range was around 6,000 meters, which was considered adequate at the turn of the century, but soon became insufficient as artillery technology advanced. The rate of fire generally ranged from 1 to 2 rounds per minute, depending on crew training and battlefield conditions. The gun was usually operated by a crew of 6 to 8 soldiers, responsible for loading, aiming, firing, and ammunition handling. The Feldhaubitze M99 entered service as one of the standard field howitzers of the Austro-Hungarian Army and remained in use at the outbreak of the First World War in 1914. However, the rapid evolution of artillery during the war quickly exposed its shortcomings. The lack of a recoil system, limited range, and relatively slow rate of fire made it inferior to newer designs such as the 10-centimeter Feldhaubitze M14, which featured hydraulic recoil mechanisms and improved ballistic performance. As a result, the M99 was gradually withdrawn from frontline service and reassigned to secondary roles or training units. In conclusion, the 10-centimeter Feldhaubitze M99 was a typical field howitzer of its era, characterized by high-angle fire capability, solid but simple construction, and limited technological sophistication. Although it was rapidly outclassed by newer artillery systems, it played a meaningful role in the development of Austro-Hungarian field artillery and provided valuable operational experience that influenced later, more advanced howitzer designs. Its historical significance lies in its contribution to the transition from 19th-century artillery concepts to the modern indirect fire weapons that defined warfare in the 20th century.
The 15-centimeter schwere Feldhaubitze M14 was a heavy field howitzer developed for the Austro-Hungarian Army in the years immediately preceding the First World War and became one of the most important heavy artillery weapons used by the Empire during the conflict. Designed and manufactured by the Škoda Works in Pilsen, the weapon reflected the rapid evolution of artillery technology in the early 20th century, particularly the need for powerful indirect fire weapons capable of destroying entrenched positions, fortifications, and artillery emplacements.
Officially adopted in 1914, the M14 represented a major improvement over earlier Austro-Hungarian heavy guns in terms of range, firepower, recoil control, and battlefield effectiveness. The howitzer had a caliber of 149.1 millimeters, placing it firmly in the heavy artillery category. It fired large, high-explosive shells designed to deliver devastating blast effects against enemy troops, trenches, and defensive structures. The barrel length was approximately 2.09 meters, corresponding to a length-to-caliber ratio of L14, which was typical for heavy howitzers intended for high-angle fire. The complete weapon system weighed around 2,760 kilograms in firing position, making it heavy but still mobile enough to be deployed as field artillery rather than static siege artillery. Transportation was normally carried out using horse teams, and later adaptations allowed for limited motorized towing. The M14 used a horizontal sliding block breech mechanism, which allowed relatively efficient loading for a weapon of its size. Ammunition was of the separate loading type, consisting of a projectile and a variable propellant charge, enabling crews to adjust firing range as required. The recoil system was hydro-pneumatic, a modern and reliable solution that absorbed the energy of firing and returned the barrel smoothly to its firing position, improving accuracy and reducing stress on the carriage. The howitzer was mounted on a box trail carriage, providing stability during firing but limiting horizontal traverse to approximately 6 degrees, meaning that larger changes in direction required repositioning the entire gun. In terms of performance, the 15-centimeter schwere Feldhaubitze M14 had a maximum firing range of approximately 8,700 meters, which was competitive for heavy field howitzers of the First World War period. The muzzle velocity was about 336 meters per second, optimized for high trajectory fire rather than direct engagement. The elevation range extended from roughly -5 degrees to +70 degrees, allowing the weapon to deliver plunging fire onto targets hidden behind terrain features or defensive works. The rate of fire was relatively low, generally 1 to 2 rounds per minute, which was typical for heavy artillery using large caliber ammunition. During the First World War, the M14 was widely deployed on multiple fronts, including the Eastern Front, the Italian Front, and the Balkans. It proved particularly effective in mountainous terrain, where its high-angle fire capability allowed it to engage targets that flatter trajectory guns could not reach. The howitzer earned a reputation for reliability, robustness, and strong destructive power, making it a valuable asset for counter-battery fire and the systematic destruction of enemy defensive systems. Following the collapse of the Austro-Hungarian Empire in 1918, many M14 howitzers were inherited by successor states such as Austria, Czechoslovakia, and Hungary. A number of these weapons continued to serve for many years, often with upgrades or modifications. An improved version, known as the M1416, featured design refinements intended to enhance performance and durability. During the Second World War, several M14 howitzers were captured or reused by Germany, where they were designated 15-centimeter SFH M14 and employed mainly in secondary roles or by occupation forces. Other countries, including Italy and Romania, also operated the weapon during this period. In conclusion, the 15-centimeter schwere Feldhaubitze M14 stands as a significant example of early 20th century heavy field artillery. Its combination of powerful high-explosive firepower, effective recoil management, and adaptability to different combat environments made it a highly successful design for its time. Although eventually surpassed by more modern artillery systems, the M14 played a crucial role in the artillery doctrine of the First World War and remained in service well into the interwar and Second World War periods, demonstrating the durability and effectiveness of its original design.
The 24-centimeter Mörser M98 was a heavy siege mortar developed in the late 19th century by the Skoda works for the Austro-Hungarian Army
entering service in 1898. It was designed specifically for the destruction of modern fortifications, reinforced concrete bunkers, and permanent defensive works that had become common in Europe by the end of the century. The weapon represented a major step forward in heavy artillery design, combining a very large caliber with high-angle fire, allowing it to drop heavy shells almost vertically onto targets protected from direct fire. The mortar had a caliber of 240 millimeters and used a short, thick barrel optimized for firing heavy projectiles at relatively low muzzle velocity, but with a steep trajectory, which was ideal for siege warfare. The M98 was mounted on a massive steel carriage with a fixed firing platform. Due to its great weight, it was not a mobile field weapon and had to be transported in several loads by rail or heavy wagons, then assembled at the firing position. Once emplaced, it offered excellent stability and accuracy for its class. Recoil was absorbed by a hydro-spring recoil system, which was advanced for its time and allowed repeated firing without the need to relay the weapon after every shot. The elevation range was high, typically from around 40 degrees up to approximately 70 degrees, enabling plunging fire against fortified targets. Traverse was limited and usually required repositioning the entire mounting for major changes in direction. The mortar fired separate loading ammunition, consisting of a heavy shell and a variable propellant charge. The projectiles were extremely heavy, weighing roughly 140 to 150 kilograms, and were primarily high explosive shells designed to penetrate earth and concrete before detonating. The maximum firing range was approximately 6.5 to 7 kilometers, which was sufficient for siege operations where accuracy and destructive power were more important than long range. The rate of fire was slow, typically about one round every several minutes, due to the weight of the ammunition and the careful handling required during loading. In combat use, the 24-centimeter Mörser M98 proved highly effective against fortresses and entrenched positions. It was deployed by the Austro-Hungarian Army during the early stages of the First World War, particularly in sieges such as those against Russian and Italian fortifications. Although later designs, such as the 30.5-centimeter Škoda mortars, eventually overshadowed it in terms of sheer power and range, the M98 remained an important weapon that demonstrated the effectiveness of heavy siege mortars. Overall, the 24-centimeter Mörser M98 can be characterized as a powerful, accurate, but logistically demanding artillery system, reflecting the transition from 19th-century fortress warfare to industrialized siege warfare of World War I.
The 7-centimeter Gebirgskanone M99 was an Austro-Hungarian mountain gun developed in the late 19th century, primarily intended for use by mountain artillery units that required highly portable and reliable weaponry in rugged terrain. Introduced in 1899, the M99 was designed to provide infantry and artillery support in areas where conventional field guns could not be deployed due to difficult topography, steep inclines, and narrow paths. Its compact and lightweight construction allowed it to be disassembled into several components, facilitating transport by pack animals such as horses or mules, which was a critical requirement for mountain warfare during this period. The gun had a caliber of 70 millimeters, equivalent to 7 centimeters, and utilized a fixed or semi-fixed ammunition system. The barrel was relatively short compared to standard field artillery, which reduced its overall weight but limited its maximum range and muzzle velocity. The M99 fired shells that could be high explosive, shrapnel, or occasionally canister rounds for close support against enemy infantry. The maximum effective range was approximately 5,900 meters, with a muzzle velocity of around 349 meters per second, allowing it to engage targets at moderate distances while remaining highly mobile. The carriage of the 7-centimeter Gebirgskanone M99 was designed as a split trail type with wooden wheels fitted with steel rims, optimized for transport over rocky or uneven mountain paths.
The elevation mechanism allowed a relatively high angle of fire, up to plus 24 degrees, which was advantageous in mountainous combat, where firing from elevated positions or targeting enemies below was common. The traverse capability was limited, requiring the gun to be manually reoriented for significant horizontal adjustments. The gun's total weight in firing configuration was about 315 kilograms, but disassembled into components, each could be carried individually, reflecting its emphasis on portability. In operational terms, the 7-centimeter Gebirgskanone M99 was employed by Austro-Hungarian mountain troops in the Balkan conflicts and the early stages of World War I, where its light weight and mobility proved effective in mountainous campaigns. However, its relatively small caliber and limited range compared to larger field artillery restricted its overall firepower. Despite these limitations, the M99 fulfilled a niche role, providing rapid, flexible, and reasonably accurate fire support where heavier guns could not be deployed. Its design influenced later mountain artillery models that sought to combine mobility with sufficient firepower to support infantry operations in difficult terrain. In summary, the 7-centimeter Gebirgskanone M99 exemplifies the Austro-Hungarian approach to mountain artillery at the turn of the 20th century, emphasizing portability, adaptability, and functional reliability in rugged environments. Its characteristics, 70mm caliber, 315 kilogram weight, moderate range of approximately 5,900 meters, and ability to be disassembled for transport made it a practical solution for mountain warfare, providing infantry units with much-needed artillery support in terrains where standard field guns could not operate efficiently.
The 30.5-centimeter Mörser M11 was a heavy siege mortar developed and used by the German Empire during World War I. Designed to destroy heavily fortified positions, this weapon exemplified the era's focus on heavy artillery for trench and fortress warfare. The M11 was introduced in the early 1910s and saw extensive use throughout the Great War, particularly in assaults on entrenched fortifications and defensive positions that could not be breached by lighter artillery pieces. Structurally, the 30.5-centimeter Mörser M11 was a large-caliber, muzzle-loading mortar characterized by its short, massive barrel, which allowed for high-angle fire necessary to hit targets behind obstacles or within fortifications. Its barrel length was relatively short compared to field guns of similar caliber, enhancing its ability to lob extremely heavy shells at steep trajectories. The mortar fired a 30.5-centimeter shell, which could weigh between 300 to 400 kilograms depending on the type of ammunition, including high explosive and specialized bunker-busting rounds. The maximum range of the M11 was approximately 7.1 kilometers, though this varied slightly depending on the weight of the projectile and the propellant charge used. The weapon itself was mounted on a robust wheeled carriage designed for limited mobility on the battlefield. Due to its weight, which exceeded 16 tons, transportation often required disassembly and movement via rail or heavy artillery tractors. The recoil system was rudimentary by modern standards, typically consisting of inclined rails or simple hydraulic buffers to absorb the tremendous force generated by firing such massive shells. The Mörser M11 could achieve a firing elevation from 40 degrees to 75 degrees, allowing operators to strike deeply entrenched positions or high-angle targets effectively. Its rate of fire was slow, averaging 1 round every 5 minutes, reflecting the challenges of handling and loading extremely heavy shells. Operationally, the 30.5-centimeter Mörser M11 was deployed in heavy artillery units where it provided essential support for infantry attacks on fortified enemy positions. It proved highly effective against concrete bunkers, reinforced trenches, and fortified towns, often being a decisive factor in breaching defensive lines. Despite its firepower, the M11 was limited by its lack of mobility, long setup time, and the logistics required to transport and supply ammunition. Technically, the Mörser M11 represents a significant step in the evolution of siege artillery. It combined extreme shell weight with sufficient range and elevation to deliver destructive fire on fixed targets, embodying the German emphasis on precision heavy bombardment during World War I. The weapon's design influenced subsequent heavy mortars and siege artillery systems, including the later Mörser M16, which improved on mobility and range while maintaining the same caliber. In summary, the 30.5-centimeter Mörser M11 was a powerful, heavy siege mortar of the German Empire, designed for high-angle fire against fortifications with a caliber of 30.5 centimeters, shell weight of 300 to 400 kilograms, maximum range of around 7 kilometers, and a slow rate of fire due to the immense size of its ammunition. Its use in World War I showcased the strategic importance of heavy artillery in overcoming entrenched defensive positions, and it remains a notable example of early 20th century siege weaponry.
The 30.5-centimeter Mörser M16 was a heavy siege mortar developed and used by the German Empire during World War I. It was designed to provide powerful artillery support capable of destroying heavily fortified positions such as bunkers, fortresses, and entrenched defenses. The development of the M16 arose from the need for a long-range, high-caliber weapon that could deliver extremely heavy shells over relatively short distances with high destructive impact. The mortar had a caliber of 305 millimeters, which allowed it to fire shells weighing approximately 300 kilograms. Its barrel length was relatively short compared to field guns, reflecting its purpose as a high-trajectory siege weapon rather than a long-range artillery piece. The Mörser M16 used a combination of heavy steel construction and a rigid mounting system to withstand the tremendous recoil generated by firing such large shells. It was mounted on a mobile firing platform that allowed limited transportation, but the overall system was extremely heavy, often requiring disassembly and transport by multiple wagons or rail cars to move it to the battlefield. Once in position, the mortar could be rapidly assembled and aimed using a combination of elevation and traverse adjustments. It had a maximum range of approximately 10 kilometers, depending on the type of shell and the charge used. Operationally, the 30.5-centimeter Mörser M16 was loaded from the muzzle, with each shell carefully placed into the barrel and propelled using separate propellant charges. Its high arching trajectory made it particularly effective against targets behind fortifications or in trenches, as the shells would descend almost vertically, maximizing destructive impact. The explosive power of its shells was considerable, capable of breaching reinforced concrete and causing extensive damage to enemy positions. The mortar saw significant action on both the western and eastern fronts, being deployed in major sieges and battles where conventional field artillery was insufficient to break enemy defenses. In terms of design characteristics, the Mörser M16 was notable for its robust construction and relatively simple mechanical operation, which prioritized reliability under battlefield conditions. It had a weight of approximately 28,000 kilograms when fully assembled, making it one of the heaviest mortars of its time. The elevation range allowed angles from around 40 to 75 degrees, and the traverse adjustment enabled limited horizontal aiming without repositioning the entire platform. Although extremely powerful, its rate of fire was low, typically around 1 round every 3 to 5 minutes, due to the size and weight of the ammunition and the need for careful aiming. In summary, the 30.5-centimeter Mörser M16 represented the peak of German heavy siege mortar design during World War I. Its ability to deliver massive shells with devastating effect made it a key asset in breaking through entrenched or fortified positions. Despite its logistical challenges and slow rate of fire, its destructive capability and strategic value were unmatched by lighter artillery pieces. The M16 embodies the combination of engineering precision, firepower, and battlefield utility that defined heavy artillery in the early 20th century.